Does everybody understand?
Sir,
Yep.
how do you get q to the power of 3? Because why don't you get only q?
Because this is a P outside.
Oh, okay. So
Yep.
it only changes when it's p, but it's q, so you don't change it.
Correct. Absolutely.
Okay.
All right. Absolutely. Right. I think, ladies and gentlemen, we need to do maybe some more complex ones so that we can be absolutely confident that when we get onto solving these, so we're going to do one more. We're going to do one more. Okay. We're going to do one more so that I can be confident that you know your stuff and then you can go and do this. Okay. Right. So let's find an awkward one for you to do. Let's find a really awkward one. Right. I think I found a horrible one. Who likes to do horrible equations?
Me.
Right.
Me.
Right. Now this is as bad as complex as you can see in school for the next couple of years. If you can do this, you can do anything. Okay, in terms of factorization.
Right.
Right. Oh, this is going to be a special one. Sorry, I'm
Or
right. I'm right.
B.
This is going to be
Why are you lying?
okay. Right. Oh, this is going to be an interesting one. Right. Right.
What?
It's horrible.
The common factor is B.
Hold
And
on.
five.
Hold
And
on.
The common factors are B and A.
Yes, B, A, and 5.
Right. So highest common factors, ladies and gentlemen. Highest common factors. Okay.
B,
B, A, and
A,
5.
and
5.
What? See that?
B, A, and 5.
Yeah, so they've all got A and B in there. So actually, AB is going to be a factor. Okay, it's going to be a factor. All right, it's going to be. So we know it's AB.
A,
Yeah.
B, and 5?
So hold yours. Hold
I
yours.
know, right? I'm just ahead.
So what's going to be the common factor here then? What's going to be the common factor? And in fact, just give me 1 second. Go and have a little think about this because this is going to be an important one. Okay. Question 4. Let me just make sure that we got the right question for you to be doing. So let's have a look. This is question B. Right. So what's it going to be, ladies and gentlemen?
It's going to be A, B, and then start the brackets.
Well, no. Think about the power. Think about
A,
the
B
power.
to the power of 5.
A, B, and 5.
No.
A, B cubed.
Fantastic. Is that you again, Leanne?
Yes.
Fantastic. Does everybody understand why it's AB cubed?
Oh, yeah, because A, B is right there. Minus A, B cubed.
Yeah, that's right. Because this will go into all of these by varying factors, by varying degrees. This expression here goes into all of them. Because what this means is just it's just what it is. But what this one is, and if I just spell it out a little bit, so we can do that. We can say we can call this
Right.
we can call this one a to the power of b cubed times
So,
yeah.
can I ask you a question? Why do you say A, B like the power? What does the power mean? Something.
Oh, right. So this is the power. So when I say it's just that when you say we've got expressions called a squared, which
Yeah. Okay.
I don't know why it's been changing today. So we've got expressions called a squared. This crazy thing has changed again.
Okay. Thank you.
So we've got expressions called. Why is this changing? Why is this? Sorry, guys, give me a second. I can't understand why this is changing. So we've got expressions called a squared, which is just a times a, and then a cubed. is just a times a times a. But when you get to higher powers beyond 3, it gets difficult to say a, if it's a to the power of 5, quintic, quartic, it doesn't make any sense. So I can say a to the power of 5. So a to the power of 5, okay? A to the power of 23, that. Okay, so it's raised to the power.
Okay.
A times 23 times. So, ladies and gentlemen, if I take out, um, this particular expression, okay, this is give me a second. So it's b. Give me a second. Where the hell's it gone? There we go. So I go ab cubed outside, okay. So I go ab cubed outside. What's inside? Number's going to be 16. It's a to the power of what?
2.
It's going to be, if I've got one a outside, 4, correct?
Ah.
I'm going to show you in a minute. So, and what's b going to be to the power of? I've got a 5 there.
2.
2.
2.
Yep.
Wait.
Yep. Carry on. Carry on. You're almost there.
Minus a
Cubed.
a to the power of 3 b 2.
And that's just -1. I'm going to go through this because I think you guys haven't fully got it. Okay. Does everybody understand how we got this?
No.
Right. Right. We're going to go through for first principles how we got this. So, if I've got, let's think of it this way. Think of it this way. Because we've determined that this is the common factor, taking it outside. Okay, there. So, I multiplied this with to get this. Remember, this is an a to the power of 1 here. Okay, this is a to the power of 1. Okay, but if it's to the power of 1, we don't write it down. We just. So, let's take the first number. We know it's a 16, and that's correct. The second expression is a. But I got an A5 here originally. But if I take an A outside, what do I need to multiply A by to get A to the power of 5? I've got to multiply it by this. Okay? I've got to multiply by this. Because A to the 5 is equal to A times
8 times 5. A times A times A times A times A times
1, 2, 3, 4.
4, 5.
All I've done, ladies and gentlemen, is say I'm taking one A outside, this one. So I'm going to put a bracket there. And how many A's have I got left inside the bracket?
4.
That's all I've done. That's all I've done. Let me do it again. Let me show you again. I could express it in another way. If I decided to take A squared outside, okay, which is, if I break it,
8 times it is right there. Then you have 8 cubed.
perfect.
Okay, I understand now.
And what I can also do, let's just go one more step. I can also,
Okay.
this is A, and it's A, what number? If I take
A squared.
perfect. That's all we're doing, ladies and gentlemen. We're just moving where the bracket goes, okay, in terms of where we know what we're doing here. So we had A to the 5 here. I've taken an A out, therefore I've got to have an A to the 4, A to the power of 4 here. I've got to. So with the same example. I'm going to do it in a different color with the same concept. If I've taken the b squared outside, okay, sorry, the b cubed outside.
So what you're telling us is that you can't times the indices, you have to add them instead.
Yes, absolutely. When you're multiplying, you add the indices. Yes, you have to add the indices. Okay, that's all we're doing. That's all we're doing. Okay. So when you come to this one, if I've taken the b cubed outside and I want to get to b to the power of 5, I have to multiply it by b squared, because again, the same principles. What I've done over there is this one. Why is this done? What I've done here is this one. Okay, for the b squared, for the b cubed, sorry, I should say. I've just, sorry, I'm being an idiot. It's that one there. Let me just delete that. It's actually this one. Okay, I've actually done this expression for the b cubed. Okay, so what I've done is I've taken the b cubed outside with the ab, and I have got to multiply it by b squared to get a b5, which is here. Okay, expression there. Okay, makes sense. Make sure you understand. Let's do the second part of the equation, and I'll do it in a slightly different color. I'll do it in red. If I've taken the a outside here, and I need to get to an a4, I need to multiply it by a cubed. Okay.
Okay.
And then, because I've taken the b cubed outside, but I want to multiply it by a number to get to b5, b to the power of 5, I've got to multiply it by b squared. Okay? Because b cubed times b squared equals b to the power of 5. Okay? Which is the original number here that we were looking at. Okay? And this becomes a 1. This just becomes a 1 because I'm just multiplying by this by 1 to get that. That's it. As I said, this is about as complex as you will get. You will not get anything more complex than this. Okay, I can promise you that. I think in the textbooks you will find this as the challenge question. Okay, this is the question that will challenge you to think harder. Okay. Just want to ask you guys one more time. I'm happy to explain this one more time to make sure that you all understand, because it's really important before we move on to the next step. Okay? Does this make sense about how we're working with powers and how we're factorizing? Okay? Let's move on. So let's go on. Somebody would like to say something? Go on. Please don't be shy. Ask the question.
I was gonna ask,
Yeah.
how do we get 1?
Okay. Because I've taken originally that was the I'll do it in red actually. Okay. In red. Originally this was the original expression, the original equation, this one here. Okay. I've taken the AB cubed outside the bracket. I've taken it outside. Okay. Here. I've taken it outside. All right. So what do I multiply AB cubed by to get AB cubed?
1.
1.
1. So remember, if I expanded this bracket out, and maybe this will make it simpler, easier to understand. Sorry. Apologies, sorry. If I expanded this bracket out, okay, this gives me a to the power of 5, okay, b to the power of 5 minus a to the power of 4, b to the power of 5 minus a.
Maybe 3.
I just expanded it out. So all I've done is just multiply that with that that with that.